Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is reverse-iterators. Before proceeding, make sure that you have already watched these other videos first. This copy function uses a local iterator variable called PIIterSource, iterating from a begin position to an end position, causing the copying of a source vector's items into a destination vector. C++ has a built-in copy algorithm which has been implemented similar to this code, except the built-in implementation uses templates so that it can generically copy from any kind of collection to any kind of collection. Now assume that our goal is to reverse the item's order while we are copying them, still using the same copy algorithm. If you had tried to achieve that reversal by specifying source iterators in the opposite order, that wouldn't work, because this while loop's stepping uses a ++ operator, and repeatedly doing that ++ wouldn't ever get you from the end position to the begin position. Instead, use reverse-iterators. This rBegin function provides a reverse iterator at the same position as end. This rEnd function provides a reverse iterator at the same position as begin. Now, the same copy algorithm can still be used, but where that algorithm does PIIterSource++, the reverse-iterators ++ operator implementation has been defined by C++ to convert that request into an ordinary iterator decrementing action. This creates a kind of twist. The same ordinary algorithm thinks it's processing the source items in a forward direction, but because of this twist, we're actually stepping through source items backwards as we copy. Be aware that algorithms still expect rBegin to be inclusive and rEnd to be exclusive. Thus, the reverse iterator's dereference operator has also been redefined by C++. That dereference operator has been written to actually dereference the memory that's one item to the left of what the iterator is currently pointing at. To understand this better, consider where our iteration now begins. We now call rBegin, which returns the same as an ordinary end position. The algorithm expects to be able to access some item at that position, which it can, because the reverse iterator's dereferencing will access memory that's one item to the left of that position. And one item to the left of the end position is the last item in the collection. So iterating backwards starts at the last item in the collection, as we would expect. Also consider where our iteration ends. Ordinarily, the final item we would try to dereference would have been the prior item before reaching some end position. But now it's the prior item before reaching the rEnd position. That rEnd position is the same as an ordinary begin position. Since we're moving backwards, the position prior to that is begin +1. A reverse iterator's dereferencing will access memory that's one item to the left of that begin plus 1. As a result, the final item we dereference will correctly be the collection's first item. You could cast between a normal iterator and a reverse iterator. A reverse iterator is compatible with any type of collection class.